You've heard me make the claim, Reprap Firmware is superior to Marlin. And the overarching reason for that is macros. Now, with Marlin firmware, you as the user are forced to manipulate the base code of the firmware every time you want to do a configuration for a specific printer. And that's not good. Users shouldn't be touching the code base. Contrast that with Reprap firmware, which comes pre-flashed on the Duet board, and you as a user will never touch this. Instead, what you manipulate in order to configure it is the macro files. And you can change those macro files at any time. It doesn't just have to be a set at one time and then you can't touch it again. And they're very easy to change. You just save the changes and restart your board and everything will work. Not only that, it's just super easy to do the install as a user. It's pretty much 2 steps. Step 1, set up your Wi-Fi network and password. You do that by connecting the Duet board with a USB cable. Step 2, log into the Duet board through the Wi-Fi web-based interface and just download the configuration files, which you can get from me in the description down below. And then you're done. So it's like 10 seconds. It's that easy. Of course, you wouldn't be watching this video if you didn't want to know how I accomplished that installation. So stick around and I will show you guys exactly how I did that, especially for those of you who are going to be doing this installation on a printer which is not the Ender 3. So you will certainly come away knowing how to do that. But the last thing to mention here is go ahead and skip to this timestamp if you just want to see the discussion on why sensorless homing is not a good idea. So we'll talk about that in a few minutes, but first, let's get into the tutorial. The first thing I need to tell you guys is that this website exists on the Duet 3D Dozuki, kind of the wiki for Duet. And this is detailed instructions, everything I'm going to go over in more detail. And it's a series of tutorials actually, because you can click right here to the next, which is wiring your Duet and so on and so on. Anyway, that's going to have all of the questions answered if you have questions above and beyond what I'm about to show you. Because what I'm about to show you is just the quickest way to get your Reprap firmware installed on your Duet Wi-Fi. So we need to first plug in the Duet Wi-Fi via USB to our computer. Then open up a terminal program. I'm running YAT. And once you're connected in the command line, and yet here it's down at the bottom, you can type M552, enter. And that's going to return this line that tells us that the Wi-Fi module is turned off. It's idle, but that's okay. That tells us that we are definitely connected to the board and we're on the right track. So the next thing we want to do is type the command capital M587 space S. Open quotation marks. This is where you type the name of your wireless network and close quotation marks, followed by a space, capital P, open quotation marks, and you put the password to your network right here. End quotation marks, press enter. Okay, so it accepts that. The next thing we need to do is type in M552 space capital S1, and that is going to turn on the Wi-Fi for the Duet. You give it a minute and up pops this IP address. So that is what you need. That is what I can now open in my browser. So coming right here, typing it into the browser field, pressing enter. Ta-da, we are now logged in to the Duet board via Wi-Fi. So even though we are also connected with the USB, the only thing USB is doing at this moment is powering the board. And we are now in the web interface for Duet, which is where we are going to do all the other manipulating of the Duet from now on out, including sending print files. So that would be right here with the G-code files. You could just upload a G-code file and that's how you send prints, but we're not quite there yet. We need to configure this machine. And the next thing we need to do is go to the Reprap Firmware configuration tool. Link in the description below. Pretty obvious, pretty easy to find though. So yeah, starting here with the front page, it just asks us if we have any of these pre-configured printers that we want to install, and we do not, so go with this custom configuration button and click on next. here is where we start to get into the meat and potatoes of really setting up this board for our printer. Right here is the 4 types of printers that you could use. We're going to do a Cartesian. That's this i3 overhead gantry style printer that we have. Core XY, very cool kinematics. Core XZ, I'm not really familiar with. And Delta, of course, you can go see my other video on how to configure Reprap firmware on a Duet for a Delta printer. But we're doing Cartesian today. And so we're going to need to know all of this information. Now, it so happens that the bed for this printer, this is the Ender 3, and it's 235 by 235 and a Z max of 220, I believe. So yeah, you would just start filling these in with the correct values. But the problem is, like, let's look at this motors thing. What is our steps per millimeter? What is our max speed change? What is our max? We just don't know these numbers, and it would be nice to not have to figure them out. You can go and watch, Tom Sandlotterer's older videos for how to figure out these printers, these values from scratch if you're building a DIY printer. But we are not, and there should already be those numbers out there for the Ender 3, and actually there are. So this is the GitHub page for the Creality Ender 3, where they actually went full open source and released the Marlin firmware. So I have navigated through the GitHub page all the way to configuration.h. So this is what it would look like in Marlin if you were opening up Marlin in your Arduino IDE. So somewhere down here we could find, let's just look up Control F, steps per unit right there. So we're at, looks like X, Y, and Z. So we're at 80 steps per millimeter, 80 steps per millimeter, and 400 steps per millimeter. So X, Y, Z. And that's where we start to get these values from the open source, Marlin configuration file for this printer. But what if you have a printer that isn't open source and you just don't know what these values are, and you don't want to have to go to all that trouble? I have an answer for you. Here's what you do. You open up the Arduino IDE. That's the Arduino program. So just go download that and plug that board in, get it to the correct port. So tools, COM port selected, then you select your processor. These are always going to be they're going to be a 2560 or a 1280. Chances are better than not, if this is a board coming from China, it's a 1280. Very few boards have the 2560 chips these days. That is the better chip, but of course China is cheap, and so they're always putting the lesser chip. So probably a 1280 chip. And then you want to select your board here as an Arduino, Genduino Mega or Mega 2560. So when you've got that set up, you can then go Tools, Serial Monitor, and in your serial monitor, make sure your baud rate is set correctly. It might be 9600, it might be 1280, I don't know. At any rate, this board, which is the one that came off of the Ender 3 here, is set to 115200 as the baud rate, and you can see we're just given that. So if I just clear this output, we have nothing contaminating what we're looking for. And now this is the Marlin command, capital M 503, enter. And that gives us all of the values that we're going to need. There's our steps per unit. There's our maximum and minimum feed rates, accelerations. So those are the values that we need. So instead of going to the hard task of figuring all that out, we can just get this configuration off of any Marlin board with that 503 command. Now, I think if there's some random person out there who's using Repetier or trying to get this off of a board that was running Repetier firmware instead of Marlin, I think it's M505 instead of M503. But yeah. Anyway, so now that we've got our values, we can start plugging them into the configuration tool. But there's an easier way. So navigate back here to the Start tab. At the bottom of the screen, click on Use Existing Configuration, and then double click on config.json. That's a file you can get from me, link in the description down below. Now you'll see that basically every one of your tabs has the values for the Ender 3 already pre-entered into the fields. So you can use this as a starting spot, and if you want to do any modifications, you can do them here through the configurator. But it's even easier than that, because if we navigate back to the IP address, that's the one that was given to us when we set up the wireless configuration there, And we're in the printer. We're controlling the printer or the Duet board now through the web interface. So on the far left here, click on Settings, and then click on Upload Files. Then just click on the config.zip. You can also get this from me, link in the description. And then you just, yeah, of course you want to. And you're done. That's all it takes to install the firmware on the Ender 3 here. So if you were actually doing an install on your own Cartesian printer, not the Ender 3, and you were doing it yourself, then make sure you come through here and enter in all the correct values in these tabs, and you can see the correct values here for the Ender 3. So just go ahead and enter all of those in, and then when you get to finish, you just click on finish, and it'll download the config.g for you. You can download the JSON, and so that's, you can reopen that up in the web page again, or you can download the config.zip. And of course, just click this upload files button here to upload that config.zip, and you're off to the races. Final step to get printing is to level the bed using the BL Touch sensor. And here on the Duet Dozuki website, I'll post a link. Anyway, here is the instructions to get that working. But as usual, I have an easier way. You can just log into your the Wi-Fi into the board here. Go down to your macros folder, and then let's make a new directory, and we will call it Changing Nozzles. The reason I'm labeling it this is that we're going to have to change, or we're going to have to do these steps every time that we want to change nozzles. We're going to have to do this same thing. So in case you didn't follow that, I basically just created a folder, uploaded the macros that you can get from me, and then we're good to go. So now I just have to follow these steps here in the machine control. So you can see on the right here, user-defined macros, click on changing nozzles, and then let's just go down the line here. We're going to start with home and heat for removal, move to Z3, and then we have to go over to the printer ourselves. So we'll just click here, and we can see that it's getting up to temperature here. Now this is not strictly speaking necessary for this very first time, although every time you're going to change nozzles, it will need to be up to temperature because you'll need to break it free from all the old filament inside of the nozzle. It also helps to, if there's any sort of like dribbly bits of filament hanging off the end of the nozzle, this helps to make that molten so that it doesn't interfere with the paper measuring that we're about to do. Okay, so once that's up to temperature, we're just going to go back to here and click on the move to Z3. And now we're going to use these buttons to lower the nozzle, actually all these Z- buttons here, to lower the nozzle down to where it's touching the paper. But of course, I'm going to do that on my phone at the printer. And now that that's done, we'll just go back here to changing nozzles and reset Z, lift and probe. Watch this fanciness. So that just measured a single point, and it spit out a value of Z equals to 0.64. So this right here is our trigger height. So we're going to go into Settings, System Editor, config.g. Here under Z probe, we have G31, which is set probe trigger value. And the Z needs to be set to 0.64 now. And we'll just save that. And if you did everything right, you should be ready to print. Of course, I do have a couple other macros files for you guys. Fix errors and preheat. And going back to machine control, we can see what these do. So under fix errors, we can reset the BL touch error that can sometimes happen. Actually, this pretty much only happens when you first turn on the printer with the nozzle touching the bed so that the probe can't fully extend. So, but anyway, that's how you just reset that error when it happens. You can disable steppers here. You can lift and home if you just want to sort of do that for some reason. I find it useful. And you can clear heating errors. So if you have like a runaway heating error for some reason, I don't know, I found that useful, so I made a macro. And under preheat, of course, you can just preheat for these 4 different materials. I almost forgot to mention a little bit of modification that you need to do to the macros here. Now this is the deploy probe.g, and you need to add an I1 at the end of the M280. This is to just invert the pin, and that's because we are not using the DuX5 or DuX2 expander. That's a daughter board that goes on top of this Duet Wi-Fi. So we did the deploy probe, and we also need to do the retract probe. I1. And once you've done that, you're finished. You're pretty much finished. I mean, of course, there's lots of tune-up still to do, but that's the majority of it. We're ready to print now, but before we do, let's talk about sensorless homing. So here in config.g, we can see on the end stops section right there, I've set up M915 for X and Y to have a sensitivity of 3. And that's not entirely correct, but it really doesn't matter because of the way that the machine logically goes through the macros when it's printing. So actually, what matters here in your homeall.g is the M915. So here, when you call homeall, it's going to do a sensitivity on the x-axis of 2. That's S2. And on the y-axis, there's a sensitivity of 3. And I've found that that works for the Ender 3. These values can go all the way from -64 to +64. So I'm darn close to 0, and that's interesting. At the end of a homeall, you can see that it does this, I set the sensitivity to 10. And that's because I don't want to get false readings. As it's printing, it tends to just pop a false reading. And so you just got to set that high enough so that you stop getting false readings. And with that sensitivity of 10, I still got some detection. Now, not always, but when I was getting some collisions, when I was trying to figure out the time-lapse photography in that video 2 videos ago, 3 videos ago, but I was trying to figure out the time lapse, and I was getting severe collisions, and probably 1 time out of 3 with a sensitivity of 10, it was detecting that. But you know what? Let's talk about this a little bit more. So as you can see, I've got auto homing working without sensors. Like, there are no switches here. I've removed the switches from the Ender 3, and it does function, and it's fine the way it is. It does work. And so this is exactly the same feature that's on the Prusa. Because this is a technology developed by Trinamic, and it's built into their stepper motor drivers. So with the Prusa, he's got it tuned perfectly, right, for that printer. And so it is working as good as it can work on the Prusa. And maybe I don't have it tuned quite as good as Prusa, but it's no matter what you do, you're going to have the problems that we're going to talk about now. And that problem is repeatability. So it's between 1 and 4 whole steps of your stepper motor that it takes for the Trinamic to figure out that it's skipping, that it's no longer moving. And that just depends on if you have the sort of averaging feature out. There's a technical name for that. But so if you have the averaging feature turned on, it's 4 steps. And if you don't, then it's 1 step. But with only 1 step, you're much more likely to get false readings. So the bottom line is that every time it homes, it's within 4 steps of the stepper motor, but that's a big variation. That ends up being 0.1 millimeters. So that's the thickness of a piece of paper, and that will register on your parts. So here I have 1 hemisphere of that print from 2 videos ago. And while this was printing, it was getting a bunch of false readings that thought it was having collisions. This is before I dialed the sensitivity up to 10. And so constantly resetting, and you can see it in the layer lines here in the middle. So here at the top, that's where I set it to 10. And here in the middle, it looks like garbage. And so if you set the Prusa sensitivity so that it thought it was constantly having collisions as well, then I'm betting you're going to get the same misaligned layers that you're seeing in this part, because this is nothing different from Prusa. I have 2660 stepper motor drivers. That's the even better chips than what you find on the Prusa. Both of them are coming from Trinamic. So this is actually a flaw of the technology from Trinamic. Now, don't get me wrong, I'm not bashing on Trinamic. They're absolutely, without a doubt, the best stepper motor driver on the market. It's just that this feature, I don't know if it can be better, and it's not good enough because having switches gets you more repeatability upon auto homing. And why does this matter? Because if you are running into collisions, you will get an ugly surface like you're seeing here. And also, let's say you have a power loss, you want it to reset to exactly where it was when it was first powered. There's a couple of other circumstances where you really do need it to auto home and continue the print. However, if you're never having that issue and you just want to have a fancy printer that doesn't have switches because you want it to look cool, this is very functional. It definitely does work. So personally, I want to run mine with switches. So I'm going to be putting those back on it and redoing the firmware. And by the time this video is uploaded, I will have a version of that firmware to include for you guys. So yeah, that's about it for this video. Thanks for watching. See you next time.